Hi guys, so thank you for joining me on this video again. This video is just a little bit further on rational exponents and how to simplify radicals. Here, the one that we're going to do, it's similar to the one that we did last time, but now I have a negative rational exponent. So we have to review quickly on negative exponents. How do we deal with them? First thing we do is I put that negative with the numerator. It can really go with the numerator or the denominator. I'm going to stick it with the numerator. It doesn't matter which one. It makes it a little bit easier when we put the negative with the numerator. So I would read this as negative 2 over 3. First thing we want to do is rewrite this. So I want to rewrite it using the properties of rational exponents that we just learned. I take my denominator and I make it my index, and I take my numerator and I make it the exponent. Once we rewrite it, then I work on simplifying. You remember which part? I work on simplifying this radical part first. So the cube root of 27, a number multiplied by itself 3 times to give me 27, that's going to be 3, right? So I have 3 to the negative 2, right? That exponent is still there. How do I deal with negative exponents? The rule, if you hopefully remember, is whenever I have a negative exponent, I can make it a fraction, and because any whole number is really a number over 1, I make it the reciprocal. If I make this fraction into its reciprocal, so 5 over 1, if I make it 1 over 5, the negative exponent becomes positive when I make it its reciprocal, okay? So then it's going to become 1 over 5 to the positive 2. In this case, it's going to become 1 over 3 to the positive 2, and I can just simplify 3 squared to give me 9, okay? So whenever we see a negative exponent, get your fraction. So in this case, the fraction was 3 over 1, and take the reciprocal of it. Flip everything, and when you flip everything, the negative exponent becomes positive. Okay, so when you see negative exponents, jot down this property, star it, highlight it, make sure you remember how to deal with negative exponents. That was back in Algebra 1, I believe. So a quick refresher. The next and last example we're going to work with in 5.1 is simplifying nth roots, simplifying radicals. That's what we've really been doing all section here, but this time let's take a look at something like this. Basically, it just combines numbers and variables, right? Before, maybe I would have just given you, okay, what's the 5th root of 32, and what's the 5th root of m to the 15th, okay? But it's just put together. Properties of radicals tells me that anytime we're multiplying in my radicand, I can separate it and write it like this. I can separate my radicand with the same radical and make it multiplication. So see how I just split that up? The 5th root of 32 times the 5th root of m to the 15th, okay? Rewriting it, and then I just work with it one side at a time, right? I can just do this. What's the 5th root of 32? So a number multiplied by itself 5 times to get 32. Trial and error on a calculator, that'll tell you it's 2, okay? And I'm going to do the same thing over here. Trying to see what I can do here. Here we go. Same thing over here. I'm going to rewrite my radical now using those rational exponents. So remember, my index is my denominator and my exponent is my numerator. By putting it back in rational exponent form, I can do this, simplify this and do this division. I can rewrite that as m to the 3rd. Okay, so now this is kind of the opposite of what we had been doing. We had been going from here, denominator, index, numerator, exponent. Now we're going the other way around. Index, denominator, exponent, numerator, simplify, and there I have the simplified expression of this problem here. Okay, so you're going to practice more of these in the try-its in the practice section. Awesome job, guys. Thank you so much for watching.